So let me repeat. Group is a pair of any set, let's say G, and any binary operation star, consisting of a non-empty set G and a rule star defined on ordered pairs of elements of G, satisfying the four conditions. Okay? So the pair of G and star is considered a group if they are closed, meaning when we operate any element of G, the result must be an element of G as well, right? Or a symbol that is for all A, B element of G, A star B must an element of G. And then the second condition, the operation star is associative. The operation star is associative. Okay, familiar na tayo sa associativity. Let's say we have the group A star B star C is just equivalent to A star, the group of B star C. This is for all A, B, C element of G. And another condition, G contains an identity element E. Okay? G must contain an identity element for the binary operation. The symbol is there exists. There exists an element A, which is element of G, where A times the identity element, or identity element star pala, star A should give us the same element. Okay, that is the definition of identity element. And then number 4, aside from the identity elements, each element of A of G has an inverse, and this inverse must be an element of G as well, with respect to your binary operation, such that by definition, this is the definition of your inverse element. If you operate using any binary operation, a specific element to its inverse, we should be getting our identity element. Okay, I repeat. If we operate any elements of G, let's say A, to its inverse, okay, the result must be our identity element. Okay, so this is your 4. We should satisfy this 4, no? You should satisfy these 4 conditions. The closure property, associativity, identity must exist, and every element of G must have an inverse, which is also belongs to the set G. Okay, set G. Now, if the pair is a group, there is this special group that satisfies commutativity. We term this as a commutative group, or other term for that is the abelian group. The operation star defined on set S is said to be commutative if, okay, by commutative law, A star B is just the same as B star A. For every pair of elements A, B, element of S. Okay. Let G be a group. Now, if the binary operation star is commutative in a group G, then the pair of the set and the operation forms an abelian group. Take note that this is already a group. We already found or verified that the pair of the set and the operation is a group. Okay. Is a group. Now, it's a matter of to satisfy or not to satisfy commutativity. If you satisfied the commutative law or property, then the group is abelian. If it's not, then it's just a group. Right? It is just a group. So take note of these conditions. So the 5th condition, pero hindi siya condition ng group eh. Condition for abelian na. the group must be commutative. Okay, with the binary operation. Right? Now let's have an example here. Example number 1. Define multiplication operation as modulo 10 in the group whose elements are 2, 4, 6, 8. Okay, 2, 4, 6, 8. How to verify if this group under multiplication modulo 10 is a group. Okay, we have to test or verify whether this group under multiplication modulo 10 is a group. So first condition, the closure property. Closure property. First, construct the table by multiplying pairs of elements in modulo 10. Now, for example, when we multiply the elements 2 and 2 under modulo 10 tayo ha, under modulo 10. So 2 times 2 is 4. 2 times 6 is 12. So 10, remainder 2. So this would be 2. 2 times 8 is 6 and so on. Now completing the multiplication table will have your table of multiplications under modulo 10. This. Okay. Now, since the result of the multiplication modulo 10 is also an element of G, then we can say that the group is closed. Okay, the group, the set is closed under pala. Di pala sa group, no? The set pala. The set is closed under multiplication modulo 10. Alright, so there, for all elements A and B, which is element of G, A times B modulo 10 is also an element of G. Right? A times B modulo 10 is an element of G. So, okay. First condition, check. The set is closed under multiplication modulo 10. Associativity. Associativity. We can actually test the associativity or associative property by observing this table. Okay, just test any 3 elements of the group with different, or of the set pala, of the set with different groupings. Let's say, for example, test tayo, no? Let's choose any element from the given group. Now, since the elements are integers, and addition is associative under set of integer, then we can say that the operation, the multiplication is associative in G modulo 10. Okay, to further illustrate this statement, let's try one example. Ba't bumaba siya? Dito na lang na para makita ko yung table. Pick any value. Let's say I need the okay, 2 times 4 times 6. Is it the same as 2 times 4 times 6? Okay, this is associativity law or property. Now, 2 times 4 times 6. What is 4 times 6 is 4.
24.
Okay, 2 times 6 is 4. Saan na ba? 2 times 6. 2 times 4. Saan ba ako? 4 times 6. Sorry. Wala na ako. 4 times 6 is 4. And 2 times 4. 2 times 4 is 8.
8, sir.
Okay. And this should be equivalent. Oops. Tanggalin ko lang si break. Ayan. What is 2 times 4?
8, sir.
We have 8. What is 8 times 6?
8.
8 times 6. Okay, 8 times 6 is 8 as well. Okay, therefore, since they were the left and the right side of the equation are equivalent, then the set is commutative under multiplication modulo 10. Okay. Then we have identity. Identity. Okay, observe muna natin. What element of the set G is operated with the other elements of G which results to the same element? Okay, naghahanap tayo ng element na kapag or when we operate to other elements of G will result to the same element. Result
6.
to the same element.
6.
That is 6. Okay. You can clearly observe that in the column of 6. Right? 2 times 6 is 2, 4 times 6 is 4, 6 times 6 is 6, 8 times 6 is 8. Therefore, 6 here is our identity element. 6 is our identity element. So, existing yung element natin. Identity element exists of G modulo 10, which is identity, which is 6. The identity element is 6. Now, existing ba yung inverses ng lahat? Last property or last condition. Last condition. Every element must have their inverses. Every element of G must have their inverses. Let me ask you, for each element, now what is the inverse of 2? What is the inverse of 2? Or it's other way of asking, what element should be operated with 2 so that the result is the identity element?
8, sir.
And that is 8. So the inverse of 2 is 8. How about 4?
4 po.
4. Inverse of 6?
6.
6. And inverse of 8, we have
2.
So every element of the set G has their inverses or has their inverse. Therefore, fourth condition is also satisfied. Okay, fourth condition is also satisfied. Thus, the system, all right, or the pair of the set and the binary operation, which is a normal multiplication modulo 10, forms a group. Okay, forms a group. And then, so we already verified that this is a group. No. Now, let's test whether this group is abelian or not. Okay. Let's test whether this group is abelian or not. So, tignan natin. Abelian group is also termed as commutative group. So, test natin yung commutativity nung elements natin under the multiplication modulo 10. We have here 2 times 2. Magkibang elements na lang. No? 2 times 4 is 8. Okay, 2 times 4 is 8. Is 4 times 2 8 then? Yes. Okay, yes. And in fact, these are ano pala, no? These are integers. And multiplication of integers is commutative. So we can use that definition. Since the elements are integers and addition is commutative in Z, then the operation binary operation is commutative in G modulo 10. Hence, the group is an abelian group. Group is an abelian. Alright? So that's how we test whether a system is a group or not. And furthermore, if the group is abelian or not an abelian. Okay, more example tayo. So, first example, this involves arithmetic modulo, no? Arithmetic modulo. And second example naman, this time, this involves complex numbers. Complex numbers. So, different systems to ha. Define the binary operation as the ordinary multiplication on set G whose elements are 1, -1, I, -I. Determine whether the system, the set G with the operation, the binary operation star, is an abelian group. So we are testing no if this group is abelian. Okay. We have to test if this group is abelian. To start with, you have to test first if this system is a group. Okay? So, test muna natin if this system is a group. Just after that, we can now verify if that group is an abelian or not. So first, closure property. Closure property. Closure property will be illustrated clearly using tables. But you may just use examples or counter examples. But of course, those examples must be true for all. So you don't have to use a specific value. No, you have to use variables, not specific example, not a specific value, but variables that would generalize the property. So instead of doing that, you may just create or construct a multiplication table. So we have the elements 1, -1, I, -I. And when we operate this, or upon multiplying any two elements on the given set G, you have 1 times 1, 1 times -1, I, -I, and so on. So based from the table, the G is closed under multiplication. Okay? Meaning to say, for all elements of G, A, and B, A times B is also an element of G. Okay? That is the closure property. Now, associativity. Associativity. Multiplication is associative under the set of numerals, either real or imaginary. So to test this, let's have one example, just to be clear. Say, pick any value. Say -1. Anak. Wait lang ha. Hello, hello. Yan, medyo nawala ako. Okay, to continue, let's test the property na of associativity. Say we have the element I times negative 1 pa lang. We have I times negative I. Is this equivalent to negative 1 times I times negative I. Okay. So negative 1, what is I times negative I? I times negative I is 1. I is 1. And negative 1 times I. Negative 1 times I is negative I as well. Multiply this to negative I. And are this equivalent? So 1 times 1 is negative 1. Is this equivalent to negative I times negative I? Negative I times negative I. Sorry, negative 1 times 1 is negative 1. What happened? Bakit hindi sila naging equivalent? There should be
Tama, sir.
negative 1, no?
Negative I.
No, there should be negative 1. So negative I, negative is positive, I times I is negative 1. So there should be negative 1. May yung table yung mali. Okay. Yung table yung mali. This is, yeah, tama na siya. Ito lang sa dulo, there should be negative 1. This is negative 1. So they were equivalent. Negative 1 is equivalent to negative 1 by associativity. Next, what do you think is our identity element? Very obvious na siya. What is our identity element? Hello?
1, sir.
1. Okay, the identity element exists or is existing. And specifically, our identity element is 1. So, letter C, okay. Inverses. Nag-exist ba yung inverses ng lahat? Of course. No? We can operate any element here to other element such that the result is our identity element. For example, 1 times 1 here is our identity. Negative 1 times negative 1 is our identity. I times negative I is our identity. Negative I times I is our identity. So those were inverses. Those were the inverses. Okay. So we also already verified that the system is a group. Okay? The system is a group. This time, let us test the commutative property. Okay, to the same group. Since the element of G are symmetric with respect to the main diagonal on the table, so remember how we test commutativity using tables during our discussions of binary operation. We're actually observing the diagonals, the symmetric with respect to our main diagonal. And our main diagonal is this. I-highlight ko na lang, no? Oops. This. Okay, mami, anak. Tingnan diagonal natin na 1, 1, negative 1, negative 1. And with respect to this diagonal, symmetrical tayo. Like for example, negative 1, negative I, 1, same din. Negative 1, negative I. And then 1, we have, what's this? I and I, and I. Lumaki lang siya. Now we have negative I. Therefore, hello. I think may problema sa Zoom. Occasionally, nag-close siya automatically or mag-isa. Ano tayo? Andyan pa kayo?
Yes, sir.
Yes,
Yes,
sir.
sir. Dito pa, sir.
Yes, thank you. Nasaan na ba? Ay, messenger ko yan. I was about to message you, pero bigla nagkaroon. Saan tayo? So, not being a group, not only being a group, test natin then if this group is an abelian or not. And we can verify that by observing the main diagonal, no? If the table is symmetrical with respect to our main diagonal. And yes, symmetrical siya. Therefore, the table is commutative and the system is also a commutative under the given binary operation. Therefore, yeah. Therefore, the group is an abelian. The group is an abelian. Okay. That is the second example, no? See tayo. Third example. Third example. Prove that the set of integers g together with the binary operation star defined on g by, we have a star b is equivalent to a plus b minus 2 forms an abelian group. Forms an abelian group. So this is your binary operation, a plus b minus 2. And our elements are set of integers. Set of integers. These are our element. So first, the closure property. Of course, you cannot test, no? You cannot construct the table since set of integer is infinitely many, or we have infinite set or infinite elements of that set. So you can just generalize, okay, the closure property. Let's say assume for specific variable, or assume a variable for that would generalize all the elements of G. For any real numbers A and B, but real numbers na siya. This should be for any integer. Hindi siya real number. For any integer. A and B, element of G. A star B is equivalent to A plus B minus 2 is also element of G. Why? Because addition and subtraction is closed under integers, right? Addition and subtraction is closed under, or I mean, integers is closed under addition and subtraction. Therefore, A star B is also an element of integer. Since the set of integers is closed under addition and subtraction, then A plus B minus 2 is an element of Z. Element of Z. Thus, yeah, this is the closure property. For any A and B element of G or Z, A plus B minus 2 is also an element of G or Z. Yung G natin, yung definition na yung ginamit natin. Baka ma-confuse kayo. Here, this is our G. And since we are pertaining to a set of integers, that's why we specifically use this symbol na lang. or set of integers instead of G. And the next, associativity. Associativity show that A star B star C is equivalent to A star B star C. Using the definition of the binary operation, this is for any integer A, B, and C. Okay, for the left side, of the equation, test natin. Let's start with A star B. A star B is A plus B minus 2 by the given definition here of the binary operation. A plus B minus 2, then we have star C. And then on the other side, hindi pala on the other side. Hindi siya on the other side. Anong ginawa dito? Tinuloy lang yung operation. Tinuloy lang natin yung operation. So, say for example, this is our A. Okay? And this is our B. Hindi pa. This is our A and this is our B. So using the binary operation, A plus B minus 2. Okay. A plus B minus 2. So this is A plus B minus 2. Okay, using this definition again, And simplifying the given, we have now A plus B minus 2 plus C minus 2. So we have A plus B plus C minus 4. This is the left side of associativity property or associative property. Now, is this equivalent to the right side of the equation? Is this equivalent to the right side of the equation? Test natin. We have A star B star C is equivalent to, by the binary operation again, we have B plus C minus 2. And if this is A and this is B, then applying the binary operation, we have now A plus B minus 2. Okay. A plus B minus 2. And simplifying this, we will have A plus B plus C minus 2 minus 2. And yes, the left and the right side of the equation by associativity are equivalent. A plus B plus C minus 4. Therefore, we can say that the binary operation is associative in the set G, or in the set of integers. Okay. Now, identity element. Existing ba ang identity element natin? How can we test that? Find the identity element E, F, G, or of G if it exists. For an instance, by the definition of the identity element, for any integer or any element of G, A star E would result to the same element. Okay? A star E would result to the same element. Okay, using the binary operation only, using the binary operation. So, applying the binary operation, the definition itself, A star E minus 2. A star E is equivalent to A plus E minus 2. A star E is equal to A plus E minus 2. And then we know that when we operate any integer A with our identity element, our result is A. Now, solving for our E would give us 2. Solving for E. So, isolate natin yung E sa isang side ng equation and then solve for the value of E. We have now 2. So, the identity element exists and is equivalent to 2. Okay? This is for all, no? This is for all. Now, although it's not necessary, pero i-test natin. Let's see if this is true. Pick any element of integer and then operate natin siya with the identity element 2 and we should be getting the same. So let's say 10. 10 star 2. 10 star 2. Okay. 10 star 2 should equivalent to test natin. We have 10 plus 2 minus 2. Okay, 10 plus 2 minus 2 is of course 10. Okay, so yes, this is kahit na anong i-operate natin, kahit 2 will always be resulting to the same element. Okay. So next, inverses. Inverses. So you already know the identity element. This time, our aim is to identify the inverse of any element from our given set. So find the inverse of A, where we know that when we operate a specific element to its inverse will result to the given identity element, which happens to be 2, right? Which happens to be 2. So applying the binary operation again, A star, the inverse of A, is equivalent to A plus the inverse of A minus 2. Okay, and we know that A star, the inverse of A, is our identity element 2. And solving for our inverse of A, we'll have 4 minus A. So this equation will give us the inverse of any element of G. 4 minus A. 4 minus A. So meaning, let's say, if our A is 10, the inverse of 10 is said to be negative 6. And negative 6 is still an element of our set of integers. Okay, negative 6 is still an element of the set of integers. Alright. To verify the inverse, A star inverse of A should result to the identity element. Okay, testing lang natin if this is true. So A star, the identity, the inverse of A. When the inverse of A is given by 4 minus A, and then applying the binary operation, we have A plus 4 minus A minus 2. A minus A, 4 minus 2 is 2. And 2 here is our identity element, 2. Therefore, this is actually our inverse, 4 minus A. Okay, so we already verified that the system is a group. But our task is to determine whether the group is abelian or not. Testing if star is commutative. So A star B is just the same as B star A, no, by commutativity. So A star B is equal to A plus B minus 2. And B star A is equivalent to A plus A minus 2. So, what happened here? We know that addition is commutative. So A plus B minus 2 is just the same as B plus A minus 2. Therefore, the 8 star B is just the same as B star A. Since A and B are integers and addition is commutative in Z, then A plus B is equal to B plus A. The binary operation star is commutative under the set G, thus the group is an abelian. The group is an abelian. Okay, any questions so far, guys? Baka mabilis yung discussion ko. Or okay lang? Nakakasunod naman. Hello?
Medyo ayos naman, sir. Ayos naman po.
Okay naman. Sige. Thank you. Example number 4. Example number 4. This time we are to apply the conditions for a group with matrices. May matrices tayo. Consider the matrices in M sub 2 of R, M sub 2 of R, or a 2 by 2 matrices whose elements are in any real number R. Let's say R is given by, we have this matrix, another, R, A, B, C, D, and I. Okay, these are your matrices. These are your matrices. Let I, R squared, R cubed, A plus, A, B, C, D be the element of our group. Let's say G. Now construct the table in multiplication of matrices in G and show that G is a group with respect to multiplication of matrices. Multiplication of matrices. To start with, let's define. Recall natin how we are multiplying 2 by 2 matrix to another 2 by 2 matrix. Recall nyo. And then susulat ko. Let's say
Zero.
A. Yes. Wait lang. Lagyan ko lang ng ano ko mga. A, B, C, D times E. Tama ba yung letters? Ito ko na lang lagay si B. Tapos dito si C. A, B, C, D, E, F, G, and then H. Okay, define lang natin. You may bring out your your copy. What?
A times E, sir. C times G.
Ulit, Marvin.
A times, sir.
A times E.
E.
And then,
Yes, sir. Tapos C times F.
dito na tayo. Parang may kulang ka.
D, sir, sa kabila.
C?
C times F, sir.
C times F.
A plus, sir. Plus C times E plus.
Sorry. This would be C, F. Yan, tama. And then next, eto muna.
Yes, sir. C times E, sir.
C times E
A, B times
plus
plus
You may open your ano, kasi di ko rin maalala. Nasa binary operation siya, no? Naka-open ko ba yung binary?
Sir, A times ano, sir?
A
A times
times...
F. A times G. Sir, hindi po C plus E yan, sir.
Wait lang. Ayun. Ito ata. Ayan, here. Ito lang tignan natin. If we have the 2x2 matrix A, B, C, D, and another 2x2 matrix E, F, G, H, then their product is given by this. Okay, AE plus BG, CE plus DG, AF plus PH, CF plus D. Copy na lang natin. Ayan. Now, applying this time with these matrices are A, B, C, D, and I. For the table, these are just some, okay? Few cases of multiplication between these 2x2 matrices. Because I cannot show you all. Kasi masyadong marami yung operations natin. So, I'll just provided 10 examples here. 10 examples. Like for example, if we are to multiply the 2x2 I, the matrix I and R will have, this is I, okay? And this is R. And applying the multiplication between matrices, we'll have, test lang natin na if this is true. AE, so 1 times 0 is 0, plus BG, where is G? 0 times 1 is 0. So 0 plus 0 will give us 0. Okay. Next. Dito tayo. Dito pala. Dito. Saan nanggaling si 1? It came from CE plus DG. 0 times 0 is 0, plus 1 times 1 is 1. Okay. And then negative 1 here came from AF plus BH. AF, 1 times negative 1 is negative 1. Our BH is 0 times 0 is 0. So negative 1 plus 0 is negative 1. And then lastly, 0 here is CF plus DH. CF plus DH. 0 times negative 1 is 0. DH is 1 times 0 is 0. So 0 plus 0 is 0. And it so happened na the result is also belongs to the set G, okay, which is equivalent to R. Yeah, lagi ka na-disconnect, Cheryl. Actually, ako rin. Na-disconnect din ako. So, yun na, no? So, the product of I and R is resulted to R. Alright, it's resulted to R. Meaning, if this is the case, one of this, hindi siya one of this, no? Meaning, it could be I. It could be I is our identity element. Okay, kasi napansin natin na if we operated I with R, the result is R. So test natin ulit if that's true. This time, let's try to operate I with other matrices. Let's say A. So A here times I would give us A, which is A. So meaning, na-verify na natin. You can try again, this time using other matrices, BI, CI, DI, or II. And makita nyo na when you operate any of our elements with I, the result is always the same element. Okay. And the next, we have RR. 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 Nawala ng connection si Charmaine. Sige. R times R is R squared. So we have a new definition here that is not listed, okay, from our given, but R squared is still an element of our G, ha? Don't be confused. Although there's no definition of R squared here, but R squared is still an element of G. Okay, an element of G. And R squared times R is R cubed. Again, R cubed is an element of G, and so on. So A times B, matrix A and B would result to R squared, and so on. So these are examples. Pwede nyo basahin na lang. And completing the table, assuming that we already completed our multiplication between any two elements of the group, then we'll have this table. We will have this table. Okay. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. So 8 by 8 is 64. We have 64 solutions. That's why hindi ko pinakita lahat. 10 lang yung nakalagay doon. Kasi masyadong marami yung 64 solutions dito. Okay. So test natin. If the group is the set G with respect to multiplication is a group or not. First, the closure property. Set G is closed based on the table. So the result upon multiplying any two elements of G is always belong to set G. Labas lang. I repeat, no? I repeat, when multiplying any two by two matrix from our G, it would result to an element which is also belongs to G. So that is by closure property. And associativity, multiplication is associative on the set. So we have to test its associativity, no? Okay, we have to test the associativity by assuming for specific case. Let's say this is the case. We have D times R squared times B. By associativity, is it equivalent to D times the quantity R squared times B? Okay, copy ko lang ha. Kasi I need the table. We need the table. Okay, test natin. These are equivalent. What is D times R squared? We have D times R squared is C. Okay, this is C. And C times B, C times B is R. Okay, C times B is R. Therefore, the left side of the equation is R. And the next, R squared B. R squared B is A. Okay, A. And D times A, D, where? D times A is R as well. I is R. Therefore, this specific case illustrates the associative property. Okay, this specific case illustrates the associative property. So we'll now assume that this is true for all. Okay, this property will true for all pair, or well, for uh, all elements of G with respect to multiplication. Okay, when applying this property. And identity element, this is what I'm telling you a while ago. So nakita natin na if we multiply the matrix I to any of the other matrices, this will result to the same matrix. Okay. So this is actually our identity element. And the inverses, of course, meron silang inverse, pero observe na lang natin yung table. If existing sila. Okay, the inverse of I is I. Kasi when we multiply the matrix I to matrix I, the result is our identity element I. The inverse of R is R cubed. Okay, the inverse of R here is R cubed. The inverse of R squared is R squared. Okay, the inverse of R cubed is R. Okay. The inverse of A, the inverse of A is A. The inverse of B is B. And then that's it. The inverse of C is C. The inverse of D is D. So the inverses exists. So you already verified that this is a group